Whenever those boots try and drag you back home, the man who left us still astray. And every bump in the road was another punch that you told yourself you would no longer take. Photos on the wall remind you of dreams you erased. No letters of love you could not save. Your friends raise their glass to forgotten days of the past. Your mother can't help but notice you've changed. For the moon and weep for the stars, as you fall away at the siren bars. Dream up getaway plans and draw lines in the sand. Maybe someday we will gain the upper hand. Danke, thank you. Quick tuning action. Hello world, hello YouTube, hello everyone out there. Welcome to the COVID-19 challenge. Big thanks to Simon for letting me play one or two quick songs. Excellent. I'm a bird sitting in a cage under my wings. It's a world burning with rage. I'm a bird tied to a chain. You can clip my wings and kick my shins, and though it stings, it'll never make me change. I'm a bird now, shot out of the sky. Though you made me dig my grave, you won't kill my will to fly. A bird shot down from the sky. It clipped my wings, won't kill my will to fly. Salt of the earth and tears on the ground, jaws of the hounds that hunt me down. I ain't no bird afraid of flight, ain't no man afraid to fight. Oh no, oh no, oh no, no, no. I'm a bird now. No, no, no. Thank you very much. It's getting hot in here.
Thank you, Nimo. Thank you very much.
Thank you.
Yeah, great. We'll get some more of his guitar playing skills and singing skills later on. Hello there. At the end of this event. So I'll put this to the side a little bit. So welcome everybody to this live kickstart of the first challenge, which we worked for very, very hard as a very large team for the last couple of months. I'm really excited to see all of you guys there outside on YouTube watching us here, and also being excited to start the real thing. So let's get to our first slide. I'll announce a little bit what we're going to do today. I don't know if you can see it. I hope it very much. So this is our agenda today. I'll make a quick intro. My name is Simon. By the way, I'm an orthopedic surgeon. I'm working together with software engineers for many, many years. So that puts me into this place, obviously. Then Ahmad will take over, talk about the challenge design, which is really important for you guys who want to participate. Then Anis will take over and talk about community engagement. So this will, maybe you heard of it already, those hunters and rangers. What is this all about? How will you guys be able to interact with each other, but also with us? Then we have a word from our sponsor. We have Andreas Gieser, the CEO of Snke OS here, who will join me on the stage and we'll talk a little bit about Snke OS. It's exciting. Then I'll introduce the C19C team. So we go through some slides so you see the faces. So when you interact with them later on Discord, you know who this is, okay? So, and you will see some of them on stage today as well. And then we'll have the micro challenge explained by Ahmad as well. So the micro challenge is something we put before the real challenge. It's a very short duration. It's an easy task to do, but very exciting. Then we'll, if God lets us, the internet god, will have a live presentation of the Eisen platform on AWS done by Fausto, who is right now in Sicily, so roughly 2,000 kilometers away from here. That's also like, that was the first thing that took us a couple of minutes to figure out to get the sound there all right before we had this problem with YouTube. That's why we started a little bit late. Then in the end, there will be a panel discussion. So that is the part when we're open for your questions, which is really important. That is what really is the spirit of this challenge, that we interact with you guys. And so we really encourage you to use the comment function in YouTube and just post all the questions you have. And Florian, who's our producer today, he will select the comments and display them for us. So I can discuss that later with Anis and Ahmad. So hopefully we'll be able to answer all of your questions. And then in the end, Anis will tell you what's next, so what will be the next steps. So let's start. The obvious question is, why do we do it? Always start with why, I learned. So obviously we've always, all of us have been affected by COVID-19 disease. Here in Germany, we thought a really big wave would strike us when we saw what happened in Italy. As you probably all of you know, we got spared pretty much from it, so we were really lucky here. But other parts of the world are still suffering a lot. So there's really something to do there. There's a need to contribute with whatever you can. And we thought this is something we can do actually to contribute and help. Also, we are very curious. We love to learn. And this is something really new and exciting. So we want to share this experience with you. And also, we enjoy very much working together with brilliant people that are dedicated to the cause, just like you and everyone else in the team. So that is really what is driving us. So the problem we want to solve, it has two perspectives. One is the clinical perspective. Of course, I'm a doctor as well in the University of Munich, and we saw a lot of, especially our young doctors, just like Nima, who you saw playing the guitar. He spent a couple of months on intensive care unit taking care of patients. So I'm a little bit more senior, so I didn't have to do it. But this is a lot of work, and when you see how people suffer, you know that there's something you have to do against that. And a lot of papers were published on AI helping to fight COVID. And obviously, there is still a lot of stuff to do there. And from the scientific perspective, there's the problem. You never have access to data. If you have, data is not really good. It's not well annotated. So you really have to spend a lot of time working on the data before you can actually do your machine learning. So that is something we want to solve. So why create a challenge out of it? So we believe that we have to, questions? Yes? Oh, I'm sorry, I don't know what you mean. Can you please tell me? Oh, there's a question. Will the recording be available on the channel for those who couldn't watch it live? Yes, we'll have it later on. So if you don't have time because we started late, sorry for that. You can watch the recording, yes. So what we believe in is that the clinical problems have to be defined by clinicians, and data scientists have to take care of real problems, of course. But what we really believe in even more is that crowdsourcing something like that really makes sense, because it's not a centristic approach where you say, okay, just believe us, we're the smartest. No, the smartness and cleverness is out there. So we like to make this data and infrastructure accessible to you guys so you can come up with the best solutions. And the problem obviously is that health data is really protected, especially here in the EU. So we cannot just give it for download. I think a lot of people probably ask that. Why don't you just let us download the thing? This is not possible because this is really current actual data of patients, even as it is anonymized. We don't want to share it. That's not really a proper thing to do here legally as well. So we thought we'll do something else and make it possible. And the results should be accessible to the public as open source, please. So you can see this guy. That is the face I saw a lot for the last couple of months. Also, I heard that skepticism over the phone because we approached a lot of centers asking them for data. And of course, nobody is really happy to share data because this is not only a legal liability, a potential one, but also it's a lot of work that you have to put into getting the data to a point where you can actually transfer it. So we approached, as you can see, many academic and normal radiology departments, and in the end we got 8 of them, and we're really thankful. We owe a lot to those that actually helped us here and gave us part of their data. So this is really great. Without those clinicians cooperating with us, it wouldn't be possible. So thanks for that, but it was a tremendous workload we had to do. Okay, next one, please. So what did we do? We collected data of CTs, chest CTs, and also X-rays that come with metadata. Usually metadata means only very sparse data of the sex, the age, and the clinical condition of the patient at the time of imaging, and so on and so forth. And then we created different data sets of different quality. So what we really have complete now is the level 1 data. The level 1 data, maybe if you see it later on the slide again, consists of mainly CT data sets, right, which have a really good quality, and it has also the results if the patient had a PCR positive or negative. Of course, that's not what we need in the first challenge. I'll show you later on. But we have this amount of data, and right now we're still working in the background, like leveling it up to level 2 data, which means follow-up investigations, and level 3 data means even outcomes. Okay, next slide, please. So a lot of the work that has been done in the background, and we had a great team working on that, was quality management. You have to put it all together. You have to be sure everything's all right and everything is properly anonymized. And then you go into segmentation and annotation. So a lot of medical students have spent hours and hours painting those lungs and findings there. So you get really gold standard training data. That was really important for us. Next one, please. So we started in March 25th when the website went online in a very early stage. We got ethical board approval, and then we moved on. And that's where we are right now, August 17th, the live kickoff event today. And yeah, at this point, I think I can hand over to the next speaker. Yeah, so it's about challenge design. Ahmad, thank you very much. The stage is yours.
So, hello everyone. Yes, I can be seen. I can see myself here. So, welcome everyone. My name is Ahmad. Maybe you've already seen my name on the Discord, in the Discord server. Me? Yeah, no. Yes. Okay. Now we're live, not only visually but also with audio. Thanks everyone. Thanks Simon for introducing me. My name's Ahmad. Maybe you've already seen me on the Discord server. I'm in this challenge mainly basically supervising this from the scientific perspective and also to help make sure that the entire challenge design is very well set up. We have great help from the German Cancer Research Center, in particular from Annika Reinke, and with a senior advisor, Professor Lena Meyer-Hein from the German Research Center, who are helping us a lot here. We're really trying to make this challenge designed thoroughly, and I'm going to go a little bit through the individual topics. As Simon already said, we have this really difficult constraint that on the one hand we want to provide really high quality data. On the other hand, we cannot give you direct access. This is just a constraint that we have to live with. And we thought about a way how to solve this. We're doing this in 2 ways. First of all, our medical partners, whom Simo already mentioned, we have 8 of them right now, they provide their data, the image data, in form of the volumes with some meta-level information to a digital biobank. That's the data coming in from the left. Then we have designed a computational platform around a recent deep learning medical imaging framework, Eisen. And we have, luckily, a core developer of this and core contributor of this framework, Fausto, who will present this later a little bit. Eisen basically wraps this data securely within an AWS instance, for which we got really great sponsored computation time by AWS. This computational platform can access the data, and you will be able to run your models on that data. But unfortunately, we cannot give you direct access. So we thought about 2 ways how to do this, how to solve this. First of all, we created a synthetic data set, which many of you have already downloaded. It shall help you to train your to develop your models locally, but also it should prepare you for what will be the data like when it's in the actual platform. And to train your models, once you feel confident with your data, once you feel confident with your model, you will be able to upload a job description to the Eisen platform, which will run your models, retrain them with computational time on AWS, for which you do not have to pay anything. It will be retrained on our actual data. You can monitor the training progress using tensor boards, and you can observe how your model performs on the actual data without the direct access. So this is the little trick that we thought about, and this is basically the entire challenge infrastructure. We had a lot of questions coming up. Can we actually use that data? And that is basically the motivation behind it. Since we cannot, we thought about this workaround, and this is also the reason why we're working with the Eisen platform, which is actually a great computational tool that allows us to realize the challenge in this manner. Snke OS is the big sponsor for the segmentation challenge, our first challenge in this setup. And the data set that we're working with is basically made up of low-dose lung CTs and with fairly high resolution, especially that first synthetic DOI data set that we gave out is on the order of 0.5 millimeter, almost isotropic. And that is very high resolution. It's manually segmented by trained medical students who have with a 4i principle, so there's some quality assurance. So far, we have 114 segmented CTs, 79 COVID cases, 35 non-COVID, and this we're going to ramp up to 150, namely 100 COVID, 50 non-COVID. This data is encoded in a multi-hot fashion, so every voxel can have multiple labels as occupancy. These labels represent the 5 different lung lobes, as well as 2 lesion types, ground glass opacities and consolidation. A little peculiarity about our challenge is that we will also provide non-annotated data, non-annotated volumes without segmentations, more than 100 of those. And that, I think, personally, from a scientific perspective, it will be also really interesting. Which team will be able to properly leverage this data, for example, with semi-supervised techniques, with self-supervision, in order to leverage this data properly so that that may just give the right edge over the other segmentation algorithms. The evaluation and the conditions. First of all, the evaluation metrics. There have already been questions by some of the participants. We will evaluate based on 2 metrics, very commonly used ones, dice overlap coefficient and Hausdorff surface distance. This will be for each lung lobe separately, as well as an average score, and we will also evaluate those scores for the lesions, ground glass opacities and consolidation. There will be a standardized evaluation script implemented both in the AWS platform, and we will also disseminate this through the Eisen platform to all participants so that we all play with the same fair set of cards, let's say. There are certain conditions. All teams must participate with open source solutions. This is this big non-profit idea that we have for this challenge. We would really like this to be a community collaborative effort to bring this research in this area forward. Due to technical reasons, we can only allow fully automatic segmentation methods to participate in the final evaluation. We've also had the question about incorporating own data. Currently, we think that it's the best if we don't allow teams to incorporate their own training data. They can play around with this, but as soon as this happens, it should be disclosed to the challenge organizers. It will not be ranked within the competition, but it would also be interesting to see how pre-trained models compare compared to the rest. But it will not be part of the ranking. And you already have heard about this distinction between hunter teams and ranger teams. Anis will give us more information about that later. And the hunter teams from the organizing institutes may participate, but they are not eligible for awards. So those are a few of the evaluation metrics and the conditions. All of that, I'm sure there are still many questions around. All of that will be summarized in a big challenge design document, which is according to the standards set up by the German Research Center and also followed by the Mikai community. This will be disseminated today or tomorrow, or definitely within this week, and a lot of the questions will be there. As I will close with any part that I'm saying today, any questions you have, please approach us on the Discord server, and we'll try to answer everything as soon as we can. Thanks a lot. Anis.
So can you hear me? So next one is Anis. She will tell us about community engagement. Like I have to say that the hunter and ranger thing, it's totally her idea. I find it brilliant. Thank you for that. And I'm really looking forward to it.
Thank you, Simon. So in the beginning of the design of this challenge, Simon and I were discussing, and we wanted to kind of bring in collaborative efforts, as Ahmad said, and how to engage people. Am I audible? Perfect. So how to engage people who don't want to compete and just want to help others, or to kind of get engaged in the sense that they would like to submit codes and they would like to just solve this problem of COVID-19. So for this purpose, we kind of came up with the concept called hunters and rangers. Slide, please. So this is what it looks like. So first group is like hunters. If you want to participate as hunters, you can participate as a team of maximum 5. You will be competing in the challenge and you will be kind of winning the prize for that. So incentive for this was given by Snke OS, and it is AWS cloud credits worth 7,500 euros, 1 Amazon Deep Razor and 2 Amazon Ecos. If you want to participate as rangers, you can participate as an individual or as a team. And in this, you will be supporting the hunters as well as the COVID-19 team by giving some kind of codes, some educational materials. It could be a Medium blog. It could be some kind of clinical information about COVID, some literature survey. If you find some technical papers that are like the state of the art, that are solving the same CT segmentation challenge, for example, you can just share it with everyone. Or we are also trying to engage the clinical people who have clinical perspective about this, so you can be a part of this challenge as a ranger as well. For the winners, we will also pick out some really outstanding rangers out of the rangers team, and this will be decided by the organizing committee as well as the hunters team. So for example, if you have submitted a code and the hunters team have used it to the maximum extent, and you get like out of 50 teams, 40 teams have used your code in some place, then you are definitely in a rank to win a prize in the rangers team. So for the incentives of the rangers team is yet to be announced. It's a surprise, so we will kind of come up with that in coming weeks. Next slide, please. So how are we going to go forward with hunters and rangers together? So first of all, both the groups, if either you are hunter or a ranger, you have to kind of go through the micro challenge, as Ahmad already mentioned, and will be describing it in details later. You have to qualify by solving this small micro challenge, which is also a CT segmentation challenge, but on a toy data set. And once you qualify this, then you will enter the real challenge, and hunters will be, as I said, competing, and the rangers will be supporting them. Next slide, please. So far, this is the status of applications. We have 49 hunters teams who have registered and 12 rangers teams. So with this, I will finish my talk and hand it over back to Simon. Thank you.
Thank you very much, Anis. I have the honor to welcome Andreas Giese, who is the CEO of Snke OS, which is a company probably not many of you have already heard of. So here I am. So I'll take the opportunity to have a little fireside chat with him and get maybe some answers on that. Okay, let's get ourselves some chairs.
Just got my voice.
Great. Okay. Okay.
All right, thank you.
Yeah, welcome for making it here. You're a company from Munich, so it wasn't so far, but in COVID times, you never know, right?
You never know. So thank you very much for having me and actually being part of this exciting challenge. So first of all, Snke OS, I think most of you haven't heard the name yet. It's actually brand new, but most of you hopefully have heard the name BrainLab. So actually, Snke OS is a spin-off, it's a carve-out of BrainLab around everything that we're doing with medical image processing, building a digital health tech platform for mostly surgeons, but actually looking at all other clinical disciplines as well, and mostly about AI technology, big data analytics, all the big mega trends right now are part of that. It's very exciting. We just started about 2 months ago, actually. We took the platform team, the algorithm developers, the AI developers from BrainLab, from our Munich headquarters, about 65 colleagues, and actually moved into a new office in the Bavaria Towers over here in Munich. So not far away from our home base in Riem, where the new BrainLab headquarters is, but also having kind of the spin and the mindset to really build something new and invest in that. And we're actually hiring 100 new colleagues, mostly in terms of software developments, AI over here in Munich, but also have offices already in Tel Aviv and San Diego. So really want to go big, and this is a great chance to work on something big for something very important that everybody was kind of struggling and challenging in the last months, and also showed the importance about medical image analysis in terms of software analysis, in terms of AI development, and actually figuring out what can we do together to build something better for digital healthcare.
That's very interesting. Actually, I know the company BrainLab quite well because I already said I'm an orthopedic surgeon. I use their products. It's about computer navigation, computer-assisted surgery. So I knew that I'm your customer there, right? For Snke OS, I'm not so sure if I, as a doctor, I'm your customer. You know, who's your market? Who are you going to cater to?
Right. So first of all, we are already partners for quite a while. So I knew the whole team that was involved in talking together. So there was no question that we want to be part of that. And also, I think we were calling you, can we be part of the challenge, and not the other way around, can you be a sponsor? So I think that's quite a nice sentence. We want to be part of that, just to say how exciting this is, and also the format that you chose. So BrainLab is coming from image-guided surgery and very complex software products and innovation driver in terms of finding products for neurosurgeons, for orthopedics, and for spine surgery, for example, and also radiosurgery. But all the software we built in the last 30 years was very IT heavy, and we for quite a while we had the impression you can use this fundamental technology in terms of medical image processing, so creating a map for a navigation system. So we are a navigation company, BrainLab. Usually that means you always need a map and a GPS system. And our map is the medical or the imaging that you do of the human body, so MRIs, CTs, and the GPS system is our tracking system with infrared or video analytics that we do. And for quite a while, we had the impression you can use that for much broader use cases in clinical practice. So it's not only high specialized neurosurgery or navigated spine surgery, orthopedics. Actually, you can use that for many general surgery indications, but also you want to incorporate more clinical specialties, because it's not only our existing customers who should be involved in the process of deciding how a patient gets treated, at what time they get treated, but actually also looking into radiology, also looking into, we're coming from neuro-oncology, so also looking into chemotherapy and so on. And so our new customers will be enterprise customers. So actually we will look into promoting this on a digital platform, on a healthcare platform to medtech companies. So everybody who was partnering with BrainLab in the past will also benefit from Snke OS. And coming back to a question, so also the surgeons using different platforms will benefit from Snke OS features. So we have a bigger market, we have a broader access to our customers. We will actively support clinical organizations. And I think that's super important, because in the past we always supported clinical organizations in terms of building registries so that they can aggregate data, that they can do clinical research on the way to best practices, find new treatment paths. But we will do that more systematically with the Snke OS platform in the terms of, again, neurosurgery, radiosurgery, orthopedics, but also looking everything that is needed for developing pharmaceutical products as well. So enterprise customers, clinical organizations, medtech companies, to name two, but also other actually digital health platforms who want to collaborate. Perhaps as a final statement, we do not want to have, again, a silo effect that companies are trying to lock in data or making money with data. I think the potential is so much bigger to build services around using data, having data quality in there, incorporating academia and startup teams to work with the data, to give actually an ecosystem that you can work with that, and then bringing it to clinical practice. So we want to be the middleman, the platform, to also combining academia, startups with then that's sort of the big companies on that playground.
Okay, I understand. So from my perspective, you're bringing third-party digital solutions to my operating room without introducing necessarily a new infrastructure. It's running on your existing infrastructure.
Exactly, and we will even build, we actually will really start to refactor and rebuild that infrastructure. So it was also about time for BrainLab to really dive deep into software architecture, to incorporate the latest trends. We all know that this is accelerating from even further always, and it's hard to stay on track. So really now use this investment to completely rebuild, use what we have, rebuild this infrastructure, and bringing actually the new healthcare operating system into surgery first in the OR. But very important point, we do not want to do all the work by ourselves, right? So we are experienced in validating medical algorithms, and doing the regulatory work, thinking about data security, thinking about cyber security, not usually the big fun parts of making AI stuff, but absolutely needed. And also having interaction with other IT systems that are existing in hospital environments, so talking into hospital information system, radiology information system, and so on. But then helping startup companies, third-party companies to bring solutions into our platform, and then probably also providing that to the surgeons who want to have a specific solution that BrainLab didn't have yet in the portfolio.
Okay. I'd love to see that. One last question. As you mentioned, you're in a big hiring process right now,
right?
Looking for software architects. So if you win the challenge, is it the plus in the interview?
I think it's participating already in the challenge and actually joining that journey is definitely everybody we would love to talk to. Of course, this is probably also motivation. You started with a why in the beginning. Yeah. And also, I also have to say something about the why are we doing this challenge. It's exactly, I think it's totally the right method to even have, with some fun, to work out what are the best solutions and also identifying who's serious about participating in such a challenge and having the best ideas. And this is totally something we want to have in the Snke OS ecosystem, either with us or with our partners. We are not so, we do not have those borders anymore. So we're just happy everybody who joins the platform.
Thank you. That's a very wonderful final word. Thanks for having you here. And let's look ahead for the weeks to come. It will be exciting.
Absolutely.
So thank you very much.
Thank you very much, and good luck for everyone for the challenge.
Okay, now I'll take the opportunity to introduce you quickly to the team so you know whom you're going to be working with the next couple of weeks. And So let's start off. The two most important people for you probably will be Anis, whom you already met here on the stage, and Leila. Anis is here in Munich. Leila, she's also in the YouTube chat right now. She's from San Francisco. So she's in a different time zone, which is also good. When I'm sleeping, she's doing the work. So great. Leila, great to have you there. And it's really fun. So let's look who's else on the team. So this is the team handling the data. They did a lot of this work that we already heard, like is not so much fun, quality assurance and annotating the data. This is Istvan, Felix, and Zilat, who also handled a crowd, a team of students getting the data on a level where you can actually work with it. Next one, please. Then communication, very important as well. If you received emails over our system, it was probably from Linda. She's from Groningen in Netherlands. She's on holiday right now. That's why she cannot help here. Florian Neumeier, he's the producer today. I don't know, maybe later on we can show you him sitting behind the monitors. And Sophia, she's his assistant right now. She's handling the presentation. When I tell her next slide, she's doing that. So thanks for having you here and for your wonderful work. Next slide, please. So Ahmad, you already met him, and you already mentioned Annika. Those two are responsible for the challenge design. A lot of paperwork and thought that has been put into that. Next one, please. Then Fausto Militari. I hope that will work. He will join us on Zoom later on. He'll do a demo, a live demo on Eisen on AWS. Don't miss this, guys. This is really important. This is really exciting stuff. I haven't seen it 100% yet, so I'm really, really excited to see it. So, and then Thomas Heiliger, who's also here, and me. We did a lot of coordination, partnerships, finding the sponsors, doing a lot of legwork there, putting the team together. So thanks, Thomas, for your assistance and your help. It was a wonderful time. Okay, and also we have an expert advisory board. I think Professor Nasir Nawab is going to join us later. He promised he'll be here in 15 minutes, so let's see. And also all these other people that have been partially mentioned that are helping us in the background. Also Franz Pfister, who helped us totally interacting with the clinicians, finding out what the real problems are. And Daniel Kondermann helping us with labeling. Andreas Liebe from Unternehmertum helping us with sponsors. So it's really wonderful. Okay, next slide, please. Okay, I can hand over now to Ahmad again. Let's talk about the micro challenge. Ahmad.
All right, I'm back. Can I be heard? Everything good with the audio this time? Thank you very much. The micro challenge. Can you please show the next slide? So, as we said already, we have a particular computational platform for all the data requirements that we have. And in order to bring everyone up to speed, we thought of introducing everyone to this platform in several steps. One important part is this micro challenge. It was announced to be finished by 14th of August. That was a mistake. We missed that deadline. Don't worry, don't panic, it's not over yet. It's just going to be released today, and the links will be disseminated on the website and on our Discord. What is the purpose of this micro challenge? The purpose of it is to familiarize all the participating teams, both hunters and rangers, with the Eisen framework and our C19C software infrastructure. That's the most important part, I would say. The next one is, of course, community building. We would like to get to know you better, and probably you have a lot of questions for which you need our support and would like to get us to know, get to know us better. Another important part is that the micro challenge is sort of a prerequisite step in order to get up to speed for the next step, which is actually submitting jobs to the real data which is located behind our Eisen-wrapped AWS infrastructure. This micro challenge is, the format of it is a little Google Colab notebook. So really easy, you can even run it out of the box on Google Colab. or feel free to download it locally as an IPython notebook. It is an almost complete example to train a fully convolutional neural network, UNet model or VNet model, on our synthetic toy data set. And we've removed certain parts of that coding example, which boils down to 3 simple coding tasks which you have to fulfill. Yeah? And those coding tasks will be reviewed by our C19C team, as well as the rangers who are helping us with that. So the micro challenge contents and tasks, as I already said, it's a Google Colab notebook. It contains most of the code that you have to go through in order to run a training. First of all, it's importing Eisen and all the other required open source libraries. Then there is a large chunk of code that is dealing with data loading, particularly the toy data, and in particularly a very low resolution downsampled version of it at 4 millimeter isotropic. That is really at this point only toy data. It's for quick download speeds into this Google Colab. Yeah? The actual toy data is much higher resolution, as I said, and you can play with all kinds of augmentation techniques like to simulate anisotropic setups. Speaking of augmentation, after data loading, there's a code section in that Colab notebook that shows how to set up a transformation chain with Eisen, namely from data loading, transferring to a NumPy array, centering, cropping, transformations, random affine, and so forth, in order to augment your data, or load it and also augment it if you are running your training pipeline. Then there are 3 important parts, of course. First of all, the definition of the model. In our case, we have a simple example that is already pre-implemented and wrapped as an Eisen module. It's a VNet, and I think the first task is to replace that just with a 3D UNet, which is also implemented in Eisen. So in essence, this task can be a one-liner for you, but feel free to also go a little bit beyond, explore this framework. This coding challenge is for us to get to know you, but mainly it is also for you to get acquainted with the framework. Yeah? So replace that, play around, go a little bit wild with that. The next part is a loss definition. Yeah? We have dice loss, which is pretty common for segmentation, training of segmentation networks. It's a dice loss that is implemented, and the next task is basically to just replace that with a combined or weighted version of a loss, which is dice loss and binary cross entropy combined. Yeah? So that might require you to implement a little class derived from one of the Eisen classes, taken as an example. So that is also a few lines of code, probably around less than 20 or so. Again, something for you mainly to get to know with the documentation of Eisen, to try a little example, to get familiar with it. The third little task is to plug everything together into a validation workflow. There is already an implementation of a training workflow, so in essence it's a copy and paste, but definitely go to the Eisen documentation, figure out what are the individual components, in which order they have to appear, assemble a validation workflow, and then together you can plug all this into a monitoring workflow with TensorBoard. A few notes, as I said, these are really simple tasks, few lines of code, and ample documentation. That Google Colab notebook is more or less self-contained to walk you through this entire example. Get your support from our team, from the C19C team, and rangers via Discord. We did not really set a particular submission deadline. The sooner you are done, the sooner you can step on with the next part, which is submitting through the AWS platform jobs. And that part is really important to know. Unless you've gone through this micro challenge, it probably does not make sense to go to the next step, which is job submission. So we're really trying to kind of educationally bring you forward step by step towards submitting jobs to our platform, as we do not have the luxury in this challenge to just download the data and be done. Yeah? The submission mechanism is also explained in the Colab notebook itself. Copy that Colab notebook locally or copy it to your drive and work on Colab, that doesn't matter. Edit your code. Eventually you should upload it back to Colab, create a publicly shared Colab link, and we've created a Google form for you to submit that link along with your team name, a contact email, and whether you're a hunter or ranger. So this little form is already also online. Again, all this is described in that Colab notebook itself. And in fact, in the next session, if, as Simon said, the internet gods allow, we will have the live link to Italy, to our colleague Fausto Militari, who hopefully can demo that little micro challenge, as well as the submission platform to AWS. For now, that's again from me. Thanks a lot.
Okay, let's see. So we'll see if we can get Fausto online. I just talked with him. He's there and ready. Let's set it up.
Yes.
Okay, I can see him. Okay. So let's see. I cannot hear him. No. But I can do it like this. Fausto, can you hear me?
Yes, I can.
Okay, great. As long as YouTube hears you, I'm okay. Just we in the room can't, so we have to imagine what you're saying, okay? Okay. So I think we can start, right?
Yes, absolutely. Okay.
Okay, great.
So, thank you very much for attending. I hope you can already hear and see me. I'm in Sicily. The background is, of course, not the view that I have in this moment in Sicily, but something that, in line with the theme of the presentation. So this challenge is very peculiar for certain aspects and pretty standard for other aspects. Let's just make sure that I am being broadcast, because I am also connected to YouTube, but I don't see myself. Okay. I think
there's just a delay, Fausto. You can go on.
Yeah, but I don't think you can see my video from Zoom. You can just hear my voice, but that's okay.
We just see you, your face.
Oh, okay. So, so what I was saying is that this challenge is peculiar for some aspects and pretty standard for other aspects. We are all participating towards a solution. There is a data set, there is a task. This is what is similar to the other challenges. But what is very peculiar is that the data is not to be shared. So everything from the training to the evaluation and the validation will happen in a way that is hidden from the user in terms of data, yet being transparent in the sense that users need to be able to, a participant need to be able to see their progress and need to be able to see their training. So what we have built is a platform that allows job submission. So you can basically submit a specification of a training you want to make and have that algorithm train for you in a cluster. And then once the results are ready, you can just harvest these results, so to say, by downloading the model or by downloading the logs in terms of TensorBoard summaries and things like this. Of course, we don't expect people to be immediately familiar with the system, because this system might result a little bit difficult to use at first. And I will explain to you why. So we have created the concept of pre-challenge to get people, so on the first instance, excited about the challenge itself, and second, to get them familiar with the Eisen and the environment. Without further ado, let me just share the screen, and then I will be able to show you some slides, hopefully. Of course. Okay. So about Eisen, I wanted to spend a couple of words. This is an open source project that aims at simplifying deep learning. Similar project to this is Fast.ai or PyTorch Lightning. There are a few different ones in the community. This is specific to medical image and makes everything very simple in terms of experimenting and developing deep learning models for medical imaging. It builds on top of PyTorch, and it aims is not to help only the beginners, but to provide advanced functionality. Actually, it even provides functionality to deploy these in an industrial setting, to deploy models in an industrial setting. And this is why actually it could be also very interesting to have a functioning solution from the community, because we could realistically deploy this one into a product pretty easily. The components that are present, as Ahmad has already explained, is dataset, transforms, models, metrics, workflows such as training, validation, testing, hooks to just look at the training and how it proceeds, losses, and a UI even. So the workflow, as Ahmad has also explained, is to import Eisen modules and other functionality from Torch into your Colab notebook in that case, and use create data loading and transformation augmentation objects, instances. So these are classes in Python, instances of classes in Python, and then to declare a dataset, model and losses, metrics, and even optimizer that gets all fused together in a workflow. Once we declare the workflow, we link all the components together and run them. So some of the features are about data manipulation, TensorBoard. So data manipulation, for example, transformation, augmentation of various sorts, and data manipulation of various sorts, dealing with for example, resizing, resampling, and things like this. And TensorBoard allows you to see the progress of your training in a TensorBoard that is automatically populated. So you don't need to write code to populate the TensorBoard, it just gets done automatically. We have various model architecture, UNet, VNet, high-res 3DNet, Obelisk, and others. And it supports model parallelism and automatic mixed precision for workloads that are a little bit more complicated. In this case, you will be given 3 GPUs, 1 GPU per person with 16 GB of memory. So you will not be able to do model parallelism. You will probably be able to do things like single GPU training on a pretty decent GPU, to be honest. The documentation you find online at docs.eisen.ai. So let me show you the pre-challenge notebook, and actually I will sneak here even the solution, right? So because this is the pre-challenge notebook complete, so you will want to pay attention. So this is actually not the final version of it, so I kept that one still secret. This is my own personal version. It's the one that we used to build the other, the initial one. And so what this code does is that we get the data, we unzip the data. This is pretty standard, right? You need to get the data from somewhere. This data is not the private one. This data is the toy data, which is obtained by modifying, basically by perturbating the real data in a way that probably is not anymore clinically relevant, but is very much difficult to deal with this data as much as it is difficult to deal with the real data. The hardness of the task is the same. And then we install Eisen, with the pip install Eisen, because of course it's not part of Colab. And then we go with all the imports. We want to import dataset, import the model we want to use, VNet. We want to import a few IO transforms, for example, load Nifty from file name. In fact, the data we are providing you is Nifty, resample the data, to transform it to NumPy, do some cropping, do some normalization, do a few add channel dimension, for example, to create a singleton challenge dimension or map the values. And this is, via code, you are just putting together all these different modules. And then this will be also clear from the pre-challenge code. And here we just declare some constants that are important here in the context of running the training. We then decide what models should be, what images should be read from the disk with this read transform training. So it will transform file names into images. And then there will be a few other transform, resampling, NumPy, so to bring everything to NumPy, and a few other transforms that get composed together to create a pre-processing pipeline. So here you can see a pre-processing pipeline. At this point, we declare a training dataset and a validation dataset, of course, and the corresponding data loader. This is pretty standard PyTorch. Data loader is something that comes from PyTorch, so it's pretty standard. And then we declare the model, as I told you before, so VNet with a certain number of input channels and output channels. We want that the input are the images and the outputs will be called predictions. Then we take the loss, the dice loss that will operate on prediction and labels, and will output dice loss. Then we will also wrap a metric just to have, instead of seeing the loss, we see the metric on a thresholded image. and then optimize. We create then a training workflow. So training, the model is our model. The losses, you can have a list of losses. If you have a list of losses, all of them will be considered. You need to weight them differently if you want to realize some weighting of the losses. Then the data loader we have created before, the optimizer we have created before, the metrics, which could be also a list, and a flag that says if we should use the GPU. Of course, we are here in Colab, where we have also free GPUs, so we should use it probably. And here there are a few hooks that get called to log what's happening, and also to save the model. At the end, we just run this model for a certain number of epochs by running training workflow.run and validation workflow.run, because of course there is also validation workflow, which I didn't detail very much in the presentation, but it's basically the same as the training, but on the validation set. And of course, it does not do training, it just does the validation. But basically the steps are the same. Okay, so this is something you do in your own computer with data, which is toy data. So it's not the real data, but this allows you to play with the data, to see if a transformation you created makes sense, to see if the way you're manipulating the data, for example, deforming them or just play with it in any way that is possible makes sense. Also, this gives you the ability of creating your own code that you want to run probably on the challenge. So once you are really familiar with the code, you have ways to turn this into a configuration file that you can send to the platform. And let's go to this platform to see how it looks like. So when I connect to mxdb-compute.net, I will see this. And if we go immediately to the about part, you will see what this is. So it's a shared computational platform. This we built everything from the ground up using AWS. It was an amazing experience because AWS gives all these different tools you can build, shared volumes, and you can have a Kubernetes cluster, and everything actually runs on Kubernetes. We have an availability of a number of nodes that is reserved for you, like in the sense they get spinned up and down according to needs, but in general, they have been reserved for the challenge. So here it's written what this is. And then here there are a few tips. How do I write a job configuration file? How do I launch a job, like a training job or a training validation job? How do I monitor my training job? So there are even little videos here which you can look at to see what happens. And how can I write custom code if you want to create code and call it from the challenge? So we will need to review that code, and that code will need to be open source, but you are able also to contribute your own code. And how do I download my models? And is there any way I can play with this data on my machine, which is what I just showed you, basically, the toy dataset. So let's switch again to the jobs tab, and now I can log in. I will use my login data. May I log in? Okay, so you see I have already one job, this new job, but let's go ahead and submit a new one. So let's give a job name, demo job, and let's run it for 100 epochs. Let's use as data set the COVID-19 public data. Why don't I see the private data here? It's because we didn't physically uploaded it yet. We are, because the challenge starts today, but here you will be able to see COVID-19 private data. Then JSON configuration file, and we upload this file. But wait a minute, what is this file? So I showed you here a Colab notebook with all the code that realizes training. But now I am not using a Python file or a notebook file here. I am using a configuration file. What does it mean? So a configuration file actually expresses in a domain-specific language, DSL, that is specific to Eisen, the same step we have done during the Colab notebook. Very similar steps at the very least, okay? Maybe not exactly the same, but very similar steps. And so, for example, we have this general section, right, where we have hyperparameters. Then we can decide the number of workers and the batch size. Then we have the section models, where we declare which models we want. We want the Eisen, those models, segmentation, VNet, VNet. And then what should be the inputs of this model? Remember, before it was, the inputs was image, and the model would produce predictions. And you can see it here, right, reflected. How many channels is the input? How many channels is the output? Number of filters. So this is a JSON file that is just deciding and showing or defining and showing what needs to be done. And this is interpretable by Eisen. So as you can see, there are two ways to talk to Eisen. One is to import Eisen in your Python. And then there is this other way, which is the Eisen CLI way, how you use Eisen without coding. Okay, now you can see that this code, this JSON file is almost like code. Maybe it's not code per se, but it's kind of complicated to do. So one way that you can mitigate this easily is to go to this website, builder.eisen.ai, and you can go you can do some sort of visual model building where you just drag and drop. You say, okay, select hyperparameters, batch size. How much is the batch size? 2. And then you say, okay, let's select a model. Let's drag and drop VNet. Okay, fantastic. So what are the inputs? What are the inputs? Are the images? What are the outputs? The prediction. How many input channels? 1. How many output channels? 7. We have 7 labels. 16 filters, and so on. So you basically can do the same file that I just showed you, but you can basically create it. In first instance, you will create it in this way. And then you download it, get config, and you refine it, maybe. And then the thing you can do is that you submit a new job here. So you call demo job, you put the file that you just created and you say submit. So what's going to happen now is that a new Kubernetes instance is going to be spinned up in the cluster, and this demo job will start running. Now, this might take a minute because the Kubernetes instances usually are not pre-warned. We don't keep them running if we don't need to. First, because it's not a green choice to keep computer running for no reason. And second, because it's not an economical choice to keep computer running for no reason. So these computers are coming up just for you, and they are just for you, running just for you, just your job. They are dedicated to you. And you get 64 gigabytes of RAM, and you get a 16 gigabyte GPU, which is gonna carry on the 100, 200, 500 epochs, whatever you want, in a reasonable time. Once the job starts, you will be able actually to see the detail, see the output, and see the tensor board. But let's go 1 second to look how, okay, I've shown you in the builder, you have a few modules. So you need to put, for example, the losses, you have the dice loss, but maybe you want to choose a different loss, which is not the dice loss. How can you do that? You need to do a pull request to Eisen COVID-19 challenge repo. This repo is automatically linked in whatever the Kubernetes instances on Amazon. These instances here are running. So whatever code gets there, it's also available within training. So let's say you want a new loss. You will just create a new file under ops, and under ops, just put, because it's an operation, so you just put a loss there, which is like your own personal loss, you can call it. And then once you're done, you can create a pull request here, a new pull request, where somebody of the rangers will go and review the pull request and make sure that your code is not doing something weird. Because you understand, the code that is in this repo can do anything, can basically do anything it wants with the data. So we cannot have the risk of you going, or some people going, and changing maybe the data or downloading the data unlawfully. Because I mean, of course we trust our participants, but we understand this is pretty sensitive data. So we will review each and every single line of code that goes into the code base in order to allow you to innovate, to build new losses, new transformation, new models, new layers. But if you want to have this thing, the new losses, new models, new layers, you need to contribute to this repo. And automatically, they will be available to the community. You can get help by other people, because your code will be visible. They are open source by definition, because this is an MIT repo, which is giving the code out, no string attached, basically. And we will still, through Git, be able to credit you for the innovation you've done, because we will be able to see who did what. So let's see if the job here is starting, because this usually takes a couple of minutes. So I can show you the tensor board and everything. But of course, if you want, you can actually have a look here. as well. So how do I launch a job? We just saw it. So once the job is running, you will see something like this. Just give me a second. We will start again. Okay. So as you can see, there are these two buttons, which are, one is opening the tensor board, so you can see the losses, the metrics and everything. And the other is opening the job logs, which show this nice table that you're gonna see right now. This nice table with all the outputs and the dice loss metrics, or as many losses as you want. If you have many losses, many different losses, it's fine. You can still see all of them one by one. Okay, maybe we can take some questions now, because let's see if the system will start, but I can take some questions in the meantime.
Also, can you hear me?
Yes, I can.
Okay, great. Yeah, I think Ahmad already was busy answering a lot of questions that people asked on YouTube. Ahmad, are there any questions to Fausto that you couldn't answer?
This is on.
So, Florian, are there any unanswered questions to Fausto?
No.
So, one question that came up that
Just switching.
So maybe we need to repeat those.
So Ahmad, because he was busy answering questions on YouTube.
One question that came up, PyTorch Lightning, is it supported? I tried to answer it as best as I can, but maybe you can briefly make a comment on that.
Also, did you hear that?
No, if you could repeat.
The question was about PyTorch Lightning.
Yeah. Is it supported?
If it's supported.
What is supported? Can you repeat? Sorry.
PyTorch Lightning.
PyTorch Lightning. And so the reason why we cannot support other things compared to, so we just support Eisen actually. And the reason is that only Eisen has this domain-specific language which hides the code behind the configuration file. So basically, when you submit that, so if we could submit Python script, any framework could be used, even TensorFlow, anything. But the point is that we cannot allow you to submit Python script. That said, there might be some workarounds where we could, so we need to evaluate this, and we can get back to you about that. If you if you commit and you do pull request to the common repository, the common open source repository that are using technologies that are not Eisen, but still use basically the wrapper of Eisen to call these technologies. But we feel it introduces some amounts of complication. So right now we are actually just using Eisen. That's the answer, short answer.
Okay, thank you very much.
So in the meantime, you have also
Thank you
the
very much. I think we'll switch to the panel discussion because audio is a big problem sometimes, especially when you have too many microphones to count. Fausto will be on the YouTube chat as well. So if you have questions, ask them there. But also we will try to answer your questions as good as possible. So thanks, Fausto. Take care and please stay with us till the end. Potentially we have some 2 or 3 questions for you as well. Okay, so Florian, let's see what questions we have. I'll read them to you and you can answer. Yeah. Okay. Leila, she collected something from Discord. Can participants use their own in-house datasets to train the model? I think that was already briefly addressed from
I briefly mentioned that already. So In the sense of fairness, I mean, there may be centers who already have large data sets available, yeah? And that is, of course, a non-negligible advantage in such a challenge. So I think in the interest of fairness, we decided to not allow this. It can be, maybe weights can be preloaded from a trained model, but in that sense, if that happens, then the participants should indicate it to the organizers, because we would like to have that out of the competition, yeah, again, for fairness sake. Yeah.
I think it makes sense. I mean, it's so hard to get good data, and then it's not a fair challenge anymore.
Absolutely. Yeah. And on the other hand, a certain sort of model refinement anyway needs to take place due to different annotation style. And within our challenge, everything is consistent because we follow a consistent protocol. But any sort of labeling that comes outside anyway needs to be refined. But nonetheless, it can be expected that the model already has a lot of knowledge about the geometry of the lung and the lung lobes and the lesions. So I think, again, in terms of fairness, we would like to exclude that.
Thank you. Okay, Florian. So Amrit Palsing from YouTube asks, what are the barriers to share anonymized data? Well, maybe I can answer that. I mean, coming from a EU entity here, where we have to follow EU regulations, and we have something called GDPR, which is called the General Data Protection Regulation, which is kind of harsh. I mean, that's the one side. That's the legal side, that you really have to be careful, especially when it comes to anonymized data. There's a lot of discussions going on what actually is anonymized. I mean, if you see it as an absolute thing, then nothing is anonymized. Or if you see it as a relative one, I mean, that is really an open discussion still taking place. So that means if you share anonymized data of real patients, especially when it comes to CTs, I mean, you can reconstruct the chest of a patient. Obviously, it becomes even more complicated when it's about CTs of the head, where sometimes the eye portion is already still in there. I mean, that makes it even more complex. So that's the legal perspective, and the other perspective is the ethical one. And I find this very attractive to say, well, it's your duty as a doctor and also as another person, if you like to do what you can to protect your patient's identity. And so if you have the technology, you should do that. So you will probably not see a lot of data in the EU sphere being shared, especially not when it's not a university. I mean, suing a university is something, I don't know, I wouldn't do it. I mean, I think university has broad shoulders, but we are only an open source project, so we didn't want to get into any trouble. So that is the legal thing, and the ethical thing being, if you can protect the identity of your patients, you should do so, and that's what we believe in. And we think we found a very elegant way to make training possible in a convenient way and still protect the identity of the patients. And so that's the long answer to that. Okay, Leila, another community question from Discord. Is there heterogeneity in the imaging data given that it has been collected from various international sources? I think this is, should I answer that?
Yes, because it's about data collection.
Yeah, because I did all the data collection and my team did it. So yes, so that was one of the ideas, not to only take one center and take 200 data sets from them, but to distribute it not only in Germany or Europe, but also from abroad. And we really got that. We even got data from the North American continent. And so we look through it. There are different scanners. There are different ethnicities of patients and different hospitals and different protocols the data was acquired with. So we think that this is compared to what else is out there, it's a comparably heterogeneous data set, yes.
Just a follow-up question. Is
Yes.
this information given in the dataset description about the heterogeneity?
Well, in the design document, we already mentioned it. It's from several centers. I answered this question also partly in the Discord. We don't have really a summary of that. We could actually generate that. It's not a big problem. one thing that one thing that's clear is there are multiple scanners from which this was acquired. CTs are calibrated scanners, so it's a calibrated and quantitative imaging technique in terms of Hounsfield units. So there is some consistency to be expected. Noise patterns, though, are probably very different across scanners. One thing that I, from looking at the data, already know is that there's a heterogeneity in terms of anisotropy. So certain volumes, and especially the toy data set, is fairly high resolution, almost like near isotropic, 0.5 millimeter in plane, like 0.7-ish out of plane. Very high resolution, very large scans also. So that's actually pretty convenient. As a toy data set, you can play around with anisotropy because there are also volumes that are out of plane and on the order of slice spacing of 2 millimeters. So there will be some heterogeneity there, definitely. Yeah.
Okay, thank you. I think we missed a question for you. And again, from Discord, how do participants submit custom network architectures or loss functions to the challenge framework? I don't know.
I could answer this partly, but is Fausto there? Otherwise, I will answer it.
I don't know. Yeah, please do so. Maybe Fausto can comment on YouTube, and we can also see Fausto's comment here on the screen.
Again, I answered this partly already in Discord, but and I can only answer this briefly. So yes, you can implement your own models, of course, and your own loss functions. It's not that you can only use those few implementations that are already available in the Eisen framework. You can implement your own models, for example, as long as they are PyTorch models which derive from nn.module. You can use an Eisen model wrapper class, where you provide that model or your module, and it wraps around that, and then it can be used and loaded from that JSON file, basically. The same goes for losses, and that is actually part of the micro challenge. We already wanted you to get familiarized with this concept that you can implement your own models and losses. In that micro challenge, the task is to change, as I said, from dice loss to combined dice and binary cross entropy loss. And that class you may have to create yourself and then wrap it again with this with the Eisen framework. Those are just a few lines of code, and then you can incorporate that into the workflow, which is the third task of that micro challenge. So yes, definitely you can incorporate your own models and losses as long as they are PyTorch and derived from nn.module.
Great, thank you. So Don't Be Evil says, just to be sure, it's not too late to join the challenge, is it? I never heard of the Slack or the segmentation challenge.
Community.
So, this is community, clearly.
So the thing is that we have closed the registration now, and we already have the teams, but you can join as ranger. So for rangers, we might open our channel again to do the registration, and with participating as a rangers, you will kind of anyway have the access to everything that the hunters will have, but you will not be the part of competition. So that way you can participate still, but not as hunters.
We may actually also, I think.
Yeah, I think we'll extend it.
Yeah.
I think we have a lot of people watching. I think a lot of them are considering to join. I think we can leave it open for 2 more days.
Yeah.
Perfect.
What do you think?
I am up for that.
Okay, let's don't be too strict. Let's leave it open.
No, I think it should be fine.
Okay, great. Suma Paul says, can you give the synthetic dataset download link here?
Yes, we will plaster the entire community channels with that link.
Yeah.
You can be sure about that. It's already, the downsampled versions in the micro challenge notebook. We will put it in the Discord. The high resolution is currently uploading, or the upload is already finished. Fausto notified us of that. That is bigger. That's around 10 gigabytes. The small downsampled version is 74-ish megabytes. So both versions should be available by later today, and then you can download it, and we will provide that link in many locations.
And the synthetic data, it corresponds to everything in the real data, right?
Absolutely. So we wrote a little Medium article about how we did that. It's basically a way to non-linearly morph random subjects to random other subjects and stop somewhere randomly in the middle along that path It's called diffeomorphic interpolation, that process. And we use that to create a very realistic representation where all the body measures are basically non-linearly deformed throughout the upper body. That is, of course, there are artifacts in that toy data set, but I would say that those artifacts are within the range that you would also expect from your augmentation routines. So it's not really a destructive synthetization or something. And it's fairly realistic if you download
I looked at it. I find it very realistic. I think we should create a paper out of that and see which radiologist actually can pick the wrong, or not the right one, the real one, among the synthetic ones. I would be interested to that.
Let's see.
Okay, great. Another question. Maria says, do you share the video to review after? So in case you think you're talking about the video here of the live stream, it will be listed, so you're able to watch it, of course. Yes. Okay, any more? Okay, Tobias asks, is the link to the pre-challenge notebook already released?
Not yet, it will be released today, before we leave this place.
Okay, great. That's a word. Okay, great. So next one is Dieter asks, the only way to submit a job is using the Visual Builder or the JSON file?
Both ways. The Visual Builder is for convenience, and it's also originally intended as a way for people with either a little programming background or for people who just want to quickly set up a prototype. That was the Eisen way to implement that. You can play around with that, build up your JSON file. Eventually, though, we expect that many people who are participating are actually coders. So very soon, after a certain learning phase, people will be able to parse that and modify the respective parts that are necessary. That those can be exchanged then.
Okay, great. Out of interest, how do hunters maintain a competitive advantage for the final ranking if the pipeline components are always open source?
Well, yes, that's a difficult question. So we have discussed that we will give some of the rangers this task to kind of review the code on certain weekly basis or bi-weekly basis, for example, just to kind of make sure that which branch is pulled by whom, and still we will be able to kind of rank the hunters in the way who has used whose codes.
I would say we're also thinking about how to realize a really completely fair and separate code base. As our concept so far it's not really easy to realize that. So again, in a sort of community sense, I would say that we will try to check that, we will try to ensure fairness. That's completely correct. Out of community spirit, I would say it's also one of those opportunities to practice fairness across the teams. So it's sort of a code of conduct, let's say. Yeah, try to be unique, try to push the edge. Like, don't copy from others. In the sense, it's also interesting to see what in the end will come out. One of our plans is to, in the end, bundle let's say top 5 models in an ensemble and see how it performs against the rest of the models. And if those are basically more or less copies of each other, that will be a nonsense thing to do. So try to be unique, try to push the edge, try to bring in your own stuff. Don't look at the other solutions. Don't tempt yourself. Yeah? So that's our way to approach this right now. However, if we see a way to realize it in an easy way for us, then we will try to implement this still. Right now, it's not there.
Okay, thank you. The other has another question. Our pull requests of new transforms models losses will be visible to the other participants. The only thing that will be hidden are configuration parameters?
In essence, yes. Yeah. So currently, that's part of this, again, this concept of open source and publicly sharing all the models and modules. Currently, I think that's the mechanism. And the JSON file itself is not disclosed, so any sort of parameter in there. Maybe you can find a clever way to hide your architecture within that. I'm not sure about that, but maybe you do. I'm sure many of you are cleverer than me in this sense. But that is one way to set yourself apart, I would say. Yeah.
Great. Are there any more questions? Oh yeah, Angel. Please, does Eisen run under Windows 10 and support R language?
That is something that Fausto should answer.
Yeah.
I think it should run under Windows 10 because it's basically its dependencies, as far as I know, are all also pip installable under Windows. I'm actually not sure. I think it should be.
Let's play that back to Fausto. He'll answer that on YouTube right now.
Regarding R language, the entire platform is Python-based and dependent on PyTorch. So you can probably try to incorporate R code through this Python R bridge. I forgot the name of that module. Personally, I'm not an R user, so I know that you can incorporate R code through Python. But if you're looking at, for example, entire deep learning frameworks that are implemented in R, that will be tough to get it to a point that you can actually run your R-based deep learning framework within this challenge.
Okay, I think that's the last question. Can we use pre-trained lung mask model, which is a model which just predicts binary segmentation mask of lungs, the ones which help focus only on the lungs when multiplied with input CTs? That was a long question.
And I think I need to read it again. Can we use a pre-trained lung mask model? So in essence, this goes back to one of the questions before. So if you use a pre-trained model, that basically gives you a certain advantage that we would like, for fairness sake, to not allow in this challenge. Feel free to do it on your TOE data, to learn more about that data set, to better plan your approach and your strategy for your model. For competitive reasons inside the platform, I think it's already exempt by that other rule that we set up, that we would like to not have pre-trained models and external data in there.
Okay, great. Okay, then let's conclude this. You can ask more questions on YouTube, and our team will answer it accordingly. So don't hesitate. Time is not over. It's still going on. So let's go to the last part. I think Anis, that's your part, right?
Yes.
About
yes. What
where
to
we go.
expect.
Okay,
next.
let's give the stage to you again.
All right, so we have the last slide here where I will talk about what we expect next. Yes, can we go to the next slide, please? All right, so today was our live kickoff event, which is almost to end now. So tomorrow we start our micro challenge. So as Ahmad already mentioned that there will be no deadline for the submission of the micro challenge. As soon as you submit the micro challenge, you will start the main challenge as well. So that would start tomorrow. And in the entire segmentation challenge that starts from today until 18th of October, that is the duration of almost 22 months, we have certain different segments as well, so that we can build this solution together. In this, we have kept 3 virtual meetups for hunters and rangers. So first would be like on 27th of August tentatively, and here we would just introduce hunters and rangers to each other, and also we will kind of have an interactive session where we kind of get to know each other and who is from where. After that, we'll have our second virtual meetup, that is a technical session. We'll have a speaker that will kind of give some technical knowledge about how to train data and how to solve the segmentation task and some advanced topics related to that. Third virtual meetup would be a clinical feedback session. So in case you have achieved some of your results already, preliminary results already, we can discuss them with our clinical partners and get some feedback about what they think about this solution, whether this is clinically relevant or not, or also we will get some feedback from our technical team as well about our deep deep learning models and stuff. And finally, the challenge will end tentatively on 18th of October, and after that time, we will kind of declare the winners. So like this, we end our live session today. Thank you so much for watching, and stay tuned for the next coming events. I give back to Simon.
Yeah, you can stay here. We're just going to say goodbye for today. Yeah.
I think I'm fine.
You go in the middle. So we'll end this day on a good note with some music. So Nima will be playing again. And you can probably watch us a little bit drinking beer and eating. So have a good time now, because this was very stressful. So we enjoyed it very, very much. Thank you for your viewership. We saw like people, like I think we had a maximum of 70, 80 people watching at the same time. Thank you for that. Thank you also Andreas from Snke OS for joining and also supporting the challenge with an award. That's really great. That's what we need. And yeah, thank you to all the team that made this all possible. And we see each other on the next live event, right?
Absolutely.
Yeah, we'll keep you posted on that. So take care and stay with us a little bit longer and enjoy Nima playing his music. Okay, great. Thank you.
Larger than life, invincible at each other's side. And I was love, drunk on you, tore through sleepless cities wrapped in blue. The world was ours to write, fairy tales of clearly defined wrong and right. Will these memories stand the test of time? Or do we live to keep looking behind? Forever yearning to rewind. And if the hand that knew so many lines out of our hands ever so gently glides. Maybe I'll wake up in a world I recognize and feels like home. But we had yet to pay the price, 'cause the world's gone mad. Baby, I think we blew it. I dream of what we had back in the world as we knew it. Silent room, white noise on the screen. tales taught at school play out like dreams. False prophets scream, I told you so. But no one knows how tomorrow will unfold. Was our love but a town to pass through? Now a road sign in the dust behind you. Will our memories stand the test of time? Or do we live to keep looking behind? Ever yearning to rewind, and the sand that knew so many lies out of our hands ever so gently glides. Maybe I'll wake up in a place I recognize, it feels like home. We had yet to pay the price, 'cause the world's gone mad. Baby, I think we blew it. I dream of what we had back in the world as we knew it. Yeah, the world's gone mad. Open your eyes, for we must march through it. Maybe someday we will find a way back to the world as we once knew it. Maybe I'll wake up, see before my eyes new place called home. When will I pay the price, 'cause the world has gone mad, with no way to undo it. Dream of what we had back in the world as we knew it. Yeah, the world has gone mad, no way to undo it. Someday we'll find peace after the world as we knew it. Danke, danke, thank you. To whoever who's still tuned. Frost on the fields, flowers on the graves. Winter claimed the fruit of life spring gave. And as the seasons change, birds wander out of range. But in my valley I shall remain. The soil is cracked, riverbank dry. From the darkness echoes the faint cry of a wolf stalking its prey. Crimson on the grave, but such is nature's order divine. When that sways the corn, rain that nourishes my grain. All my anger and pain, I never took your name in vain. It's like these pines with their roots, like shackles to the ground. To my dying breath, to this earth I'm bound. In my sacrifice, there was no meaning to be found. When I begged you for guidance, I heard no sound. stranger to hardship, we knew illness and drought. Still we sowed to seed, still we drove to plow. Yet for testing our belief, you offered no relief, and my faith was clouded with doubts. When earth weighs the corn, rain down nourishes my grain. All my anger and pain, I never took your name in vain. Just like these pines with their roots, like shackles to the ground. To my dying breath, to this earth I'm bound. And my sacrifice, there was no meaning to be found. I begged you for guidance, I heard no sound. Now remember her face, light up with joy, blessed promise of a little baby boy. One cold night in the fall became a time of mourning, when you took them from me without reason or warning. Watched grass wither, flowers fade, my faith not wavered as I cried rivers by their graves. Oh, but time eroded me like a rock beaten by the waves, and I buried for a purpose and all that I gave. Lord, I dug for answers wherever I drew my spade. I searched for clarity in all your rivers and lakes. I sought solace in storms, the destruction in their wake. I searched for a meaning in all that I gave, until I broke under the weight of my anger and shame. For I found no meaning in all, found no meaning in all. I found no meaning in all that you claim. Danke. Ja, könnte ich gebrauchen. Sehr geil. This is why loop pedals were invented. Magic, magic. There's no break from this losing streak. Seems like bad luck stuck to the shoes on my feet. I keep crying out for relief, oh Lord, loosen your grip on me. Feels like there's nothing I can do or say. Make these dark clouds get blown away. It's too late to undo my mistakes. Now I know I don't deserve to get away unscathed, but dawn breaks, I'll wake to a clean slate and I'll be a brand new man. When dawn breaks, I'll play with new stakes and I'll be a brand new man. When dawn breaks, I'll wake to a clean slate and I'll be a brand new man. When dawn breaks, I'll regret my mistakes, I'll be a brand new man. I'll be a brand new man. Brand new man. I know she gone for good, she ain't coming back. Since she gone, this train's running off its tracks. Won't you come back? When dawn breaks, I'll wake to a clean slate and I'll be a brand new man. When dawn breaks, I'll regret my mistakes, but I'll be a brand new man. When dawn breaks, I'll wake to a clean slate and I'll be a brand new man. Dawn breaks, I regret my mistakes, I'll be a brand new man. Danke. Kommt noch was, kommt noch was. Immer noch. Oh. Nee, die habe ich vergessen. Wann ist das nächste Event? Ja. You've been lying to yourself for a long, long time. Lock these thoughts into a cell in your mind, but don't you peek inside, 'cause who knows what you will find. Milestones framed on your office walls, you can read your thoughts and you can hear them talk. losing your time, go throw up in a bathroom stall. Desk sitter photo and a phone with 6 missed calls. Tell you're coming home late, it's darkness, it's up to halls. At a party, you ain't slept in days. Strangers ask what you do and how much they pay. Live for the grind, but baby, we know how to play. They're all wearing that shark tooth salesman grin, while the quicksand slowly pulls you in. But life is sink or swim, drown your doubts on another gin. 3 a.m. and you lie awake and think. Tell you that you just need a goddamn shrink. You better just a little stressed, that's all. Ticking of the clock, count the ivy bags, falling drops. Close call for the man who lived for his job. Begged for air as he circled the drain, maybe on 2 tracks of the gravy train. Remember, the house always wins this game. You were replaced the next day. I put him to a box and got a handshake. When morning light all became quiet, and a voice inside said you weren't gonna be okay. Thank you. So I think I'm going to enjoy my beer with the other guys now. Thank you very much to everyone who tuned in. Thank you to all the amazing people who organized and participated in this event, especially my dear friend Simon. Thank you to everyone. Take care.